Hi everybody. In a series of talks, I would like to present object-oriented design patterns. In this talk, I intend to talk about Singleton pattern. First of all, let's see what is a design pattern. So Wikipedia says design pattern is a general usable solution to a commonly occurring problem. So why we should learn design patterns? Because there exist commonly occurring problems in software design. Well, and instead of spending time and thinking of a solution for these problems, we just learn to use already proposed solution. What do we learn from each pattern? Each pattern describes a problem first, then it suggests a solution to this problem. So when we study a design pattern, we need to first study what is the problem that this design pattern is going to offer a solution for. And then we need to study the way this design pattern offers a solution. Okay, we have a problem and we have a solution. One of the simplest design patterns in the object-oriented world is a singleton pattern. So suppose I define a class in my application, let's call it class A, and we know that we can instantiate this class several times in my application. So, but sometimes it happens during the design that I would like to have only one instance of a class A during the application runtime. So the problem is we desire to restrict the number of objects of class A to at most one. So I don't want these extra objects. I just want to have only one object of type class A. Let's switch to the Eclipse to see how we can solve this problem. So here I define class A, and here in the main method I define two variables of type class A, and I also instantiated two times class A. So naturally what I'm expecting is that A1 and A2 are going to hold two different objects of class A, right? And for testing so, I wrote these two lines of codes to print out the object A1 and A2. So let's run this application. As you see here, the output of these two lines here are different. Why? Because it's obvious A1 and A2 are two different objects. But the thing is that I want to prevent this situation. I only want to have one and only one instance of class A during the execution. So for doing so, first of all, I need to prevent the outside world to independently create an instance of class A. The way I can do this is to make the constructor of class A to be private. So this way, nobody can create an instance of this class. But I don't want this, right? because I want to have one instance. Okay, at least I want to have one instance. So for doing so, I define a private static variable, I call it A, of type class A. So this variable is going to point to that unique instance that I want to have. Okay, and then I define a public static method, I call it getInstance, which is returning of type class A, and by this method I let the outside world to access this unique instance. Okay, so what I do is I first check to see if that unique instance is already created or not. If it is not created, which is checked by this condition, then I create an instance of that by calling the constructor, which is accessible for this method because both of them are inside the class, and then I return that instance. So if it is already created, so the code would skip this if condition and would return that unique object. Okay, so let's get back to this main class. So as you see, the compiler complains about this code because the constructor of class A is no longer accessible because we made it private here, right? So for getting that unique instance of class A, then we need to change a little bit this code. So I call the static method inside the class A. Similarly, oops, oh, what happened? Okay. Similarly, I copy and paste the code here. So this time I'm expecting that A1 and A2 would be both the same objects. So if I run this code, as you see, I would get the same output because A1 and A2 are both the same objects. In fact, in the first case, I had this situation. I defined A1 and A2, which were referring to two distinct objects of class A. But in the second case, I had A1 and A2 that both were referring to the unique object of type class A. So if we review the singleton pattern again, so by singleton pattern, we enforced class A to only have one instance, and this variable here is defined to keep reference to that single unique instance. This line here makes sure that the outside world cannot create independently any other instance, and this code here is to provide access of the outside world to that unique instance that we defined there.